Light is too slow. Yes, the very thing we've long considered the cosmic speed limit, the fastest entity in the known universe, is far too sluggish for the future we dream of. Imagine you want to go to Proxima Centauri, the closest star to us besides the Sun. It's a mere 4.24 light years away. But if you were to hop on a beam of light, assuming you could, it would still take you 4 years to get there. 4 years, just to reach the cosmic doorstep. Now let's say you want to go a bit further, perhaps to Andromeda, the nearest spiral galaxy, a casual 2.5 million light years away. Even if you were riding a photon, traveling at 186,000 miles per second, you'd get there in time to miss the next 100,000 civilizations that rose and fell on Earth. And you're telling me that's fast? Number. In the vastness of the cosmos, light is crawling. We need to understand this, not emotionally, but scientifically, because the speed of light, while unimaginably quick on Earth, becomes almost a joke on the intergalactic stage. But let's go deeper, quantum deep. See, the problem isn't just practical, it's foundational. It's baked into the physics of our universe. Einstein told us that nothing can travel faster than light in a vacuum, and as far as we know, he was right. But why is that the case? Because light isn't just fast. It's tied to the very structure of space-time. According to special relativity, the speed of light is not just a speed. It's a conversion factor between space and time. It's the slope of reality itself. It's baked into E equals mc squared, the equation that says mass and energy are interchangeable. It is, in essence, the limit of causality. If you go faster than light, you can reverse cause and effect. But here's the kicker. That limit may be a local restriction, not a universal law. Let me explain. At the quantum level, particles don't behave like billiard balls. They behave like waves, like smears of possibility. And these probability waves can interfere, tunnel, entangle, and this is where it gets interesting. They can do things that look suspiciously like faster-than-light communication. Take quantum entanglement. Two particles, once entangled, share a kind of ghostly connection. Measure one here and the other, even if it's a billion light years away, responds instantly. Einstein called it spooky action at a distance. And while it doesn't allow for information transfer in the traditional sense, it does suggest that something is operating outside the normal constraints of space-time. So what is it? What lies beyond the light barrier? One possibility, wormholes. These hypothetical bridges through space-time could connect two distant points, allowing instant travel. Not by breaking the speed of light, but by bending the fabric of reality itself. Like folding a piece of paper and poking a pencil through it. You're not traveling faster. You're just taking a shortcut through a higher dimension. If wormholes exist, and there are serious physicists who believe they might, then the speed of light becomes less of a limit and more of an illusion. A speed trap in a multidimensional reality. But we're not there yet. In our current technological state, we are bound to rockets that crawl at fractions of light speed. Our fastest spacecraft, Voyager 1, is traveling at 38,000 miles per hour. At that pace, it would take over 70,000 years just to reach Alpha Centauri. We are snails in the garden of stars. And the reason light is too slow isn't just about distances, it's about meaning. If we are to expand, to explore, to understand, we can't be trapped in a cage built out of photons. We need a new paradigm. Because if the speed of light is the universe's ultimate speed limit, then the universe is basically unreachable. And let's be honest, that's unacceptable. Human nature is restless. We don't tolerate boundaries for long. We cross oceans, climb mountains, land on moons. We need to tear through the membrane of space-time itself and find out what's hiding in the higher order structure of the cosmos. So, what are the options? Some physicists propose tachyons, hypothetical particles that always travel faster than light. They haven't been observed, but mathematically, they're fascinating. Others imagine using negative energy to stabilize wormholes. Some talk of quantum tunneling, or using quantum vacuum fluctuations to create a propulsion system that cheats inertia itself. And then there's warp drives, not just sci-fi fantasy anymore. The Alcubierre drive, proposed in 1994, is a theoretical model where space is contracted in front of a ship and expanded behind it. The ship doesn't move through space. Space moves around the ship. And because space itself can expand faster than light, as it did during cosmic inflation, this method might not violate any laws of physics. Might. But here's the uncomfortable truth. Light speed isn't the only problem. We are the problem. We're stuck thinking in terms of engines and rockets, Newton and thrust. But to truly surpass the speed of light, we'll need to think in terms of quantum states, geometry, and information. What if the future of travel isn't physical at all? What if it's informational? Quantum teleportation has already been demonstrated over small distances. Entangled states transferred from one place to another, not the matter, but the information pattern. The soul of a particle. If we can scale this, can we upload ourselves, beam our consciousness through quantum entanglement, become travelers of thought, not flesh? Sounds crazy? So did flight. So did electricity. So did quantum mechanics. In the end, light is too slow because our ambitions are too big. The universe is expanding, not just in space, but in our minds. And while photons may dance their eternal dance through the void, we, the self-aware patterns of carbon and curiosity, must go faster. Not just through space, but beyond it. So let's break the speed of light. Not with speed, but with imagination.